Hello everyone, welcome to Genius Tutorial. So in this series we are going to take all geometry theorems, all important geometry theorems along with their proofs. And these proofs are very important as far as your competitive exams are concerned, because once you know the proof of any theorem, you can derive many results and corollaries out of it. And it's always observed that whenever you get a question based on any theorem directly, then mostly examiner asks exceptions out of it. Okay, so it's better if you know the proof of theorem along with the result. Okay, so this is our first theorem, British flag theorem, and this is called British flag theorem because if you draw a figure for this theorem, then that figure is somewhat similar to the flag of United Kingdom, British flag. And let's start the proof of this theorem, but before that do subscribe to our YouTube channel if you have not subscribed it yet, because we are going to take maximum possible theorems along with their proof, so do subscribe. Okay, so this theorem states that if a point P is chosen inside a rectangle ABCD, let us say this point is P and this is rectangle ABCD, then according to this theorem, this PA square plus PC square, this will be equal to PB square plus PD square. Okay, so let's prove it. So to prove this, we have to draw a perpendicular parallel to AD and BC, and same way another perpendicular parallel to AB and CD passing through this point P. Okay, now if I calculate PA square plus PC square, PA square is, let us name this as X, Y, M and N. Okay, we can say that PA square is PM square plus AM square using Pythagoras theorem, and PC square can be written as PY square plus CY square using Pythagoras theorem. Now this PM square plus PY square. If PY square is this, PY square can be written as BM square. No? So instead of PY square, we can say BM square. Okay, this is one bracket, and remaining is AM square. This AM square can be written as PN square. This AM and PN are equal, plus this CY square can be written as DN square. Okay, so this is nothing but this is PB square and this is PD square. So sum of square of these two distances will be equal to sum of square of these two distances. This is our British flag. Now suppose in any question, if three distances are given from a point located inside a rectangle or square, then fourth distance can be calculated. Suppose if it is given that P is any point inside a rectangle ABCD such that PA is equal to 2, PB is equal to 3, PC is equal to 4, and we have to calculate value of PD. So you can directly calculate it using British flag theorem. PA square plus PC square, this will be equal to PB square plus PD square. Okay, so just substitute these values. PA square will be 4, PC square will be 16, PB square is 9, and we have to calculate value of PD. So PD will be root 11 out of it. This much unit, this will be the value of PD. Okay, so now I leave as an exercise for you and the question that this theorem states that if a point P is chosen inside a rectangle ABCD, then sum of square of these two distances, these distances from opposite corners will equal to the sum of other two opposite corners. But if I say that this point lies outside the triangle, outside the rectangle, okay, if it lies outside the rectangle, will this theorem be applicable? So I leave this question as an exercise for you, and you just give your answers in comment section below. And that's it for today. I hope you enjoyed the session. Thank you so much. We will come up with more such sessions soon.